Welcome to a new test and teardown video. This time it's another Hewlett Packard. It should be a digital interface communication protocol analyzer. You should be able to do all sorts of different type of analysis on different things. We can even see here at the front we got the 18260A. So this is RS-232 and V24 and X21 protocols. I also got a bag up here with all sorts of plug-in. This one is the ISDN. Impressive. There's a huge connector here, and this is going to the protocol analyzer. And then we got some data and stuff like that. And what else have we got in the bag? Probably just some cables. I also got a huge set of discs. Not just these, but a lot more, and all the documentation. Yeah, see, that will be discs. So you load all the different programs into it. So this one is probably together with that one, right? And that will be the big hefty cable you use for the different plug-in modules, right? So let's try and open it and have a little look. So here is the serial protocols, and I kind of like the way that this is done. So you have this big fat flat cable going to your unit, and here you can access the different protocols and stuff. There's a little LCD display here. That is a little bit impressive, and it's of course full of LEDs and all that kind of things. So now we come to the main unit. Ain't that just pretty? So that is the 4952 protocol analyzer. And when I talked to the guy that gave this one to me, he said it was working. And just the day before I picked it up, he plugged it in and it blew up. So I have to open this one and find where is the problem. It needs a little bit of cleanup, I can see that. But isn't that just pretty sexy? So after a lot of cleaning, now the keyboard is nice and beautiful. I also cleaned the front and all that. And then I realized something. If you see the plastic here, it's nice and fine and aligned. But here, ooh, how's that even possible? Because they go into grooves and they lock. So something happened real bad to this one. I'm still trying to figure out how to pull this darn thing apart, because it just keeps interlocking and I don't know what is going on. But maybe it is in the power supply. Look at that kind of blow up here. Oh no, this is really bad. But at least I know in what direction to look, right? External video, printer. And that is the interface pod. Oh, look at that. There's a little locky thing here. So that one prevents the cables. So the mating cable got this little pin missing. So you can't plug in any other things. Oh, I was just yelling. And my wife got a little bit scared because I said, oh no, damn it, that is real bad. And I think it really looks bad to begin with. We can really see how the explosion was behind this. It's probably going to get even worse when I look at the other side, but look at that. Kapam! Really interesting. What is going on here? So here's a very interesting thing. Those plastic parts here, they are mounted this way. And look at that. Down there is the little holder thingy. Isn't it supposed to be that way? This way they kind of stay there. I think this is wrong. Because there's no way you can mount this correctly. I mean, if I do this the other way, look at that. Then the click down there. That is interesting. I should probably go and see if I can find a manual that should explain this. But at least my idea gives a good hold of these parts. Because I think it's not intentional they're gonna fall off like this. This will make it impossible to assemble. So I finally figured out how to disassemble this thing. And here in the top we had this bag, accessory bag. One of the screws in the accessory bag goes through, see, here's a hole, and it goes through to that one. And that is the secret behind opening this unit. If you don't know that, you're gonna struggle a little bit. Wow, this is a really cool, super compact design. I kind of like it with all the different circuit boards stacked up like that, and it's full of ICs and whatnot. I bet that will be the processor. And we got data storage here. Maybe there's also a little storage part, or maybe this is just a battery. So I will have a little look on that one. But first I'd like to have a little closer look at the blow up area. It looks like it's just a capacitor or something like that. I'll try and go in here and see if I can make something out of this. So I was able to get all the way in here. There's one little service unfriendly thing I want to complain about, and that is this green wire that goes to the external video. It's just stuck somewhere in the middle in here somewhere where you cannot access it. Why don't we have a little connector here, or a little pull out here or something? So now I just cut it because I can easily just solder these and put a little heat shrink. Well, that's just a little bit stupid. So I'm trying to figure out what is the source of this problem. Because when I look at this, it can, at the moment, it looks a little bit like it's the capacitors. And you would, when you see a reefer, all you do is think about that as the one to blame, right? Because that is just the way that we think. But look here. This is the mains entry filter, and there is a weld through that box of metal here. So maybe it's inside that one, and then it spit out all its guts and glory out to all this. I mean, I will try and clean everything here and see where is the problem. And why didn't the fuse blow? Well, that's because if you see mains entry, it goes to that filter unfused, and then on the outside output side of that filter, it goes to the fuse. That is the black thing here on top, and then you have a mains switch. So that will be the fuse, and it's located after the filter. So that explains a little bit all this, the energy that can happen, right? Now I am down to the second layer here. I took out the disk drive. It is a very, very heavy disk drive unit. So that is mounted here. And then there is a disk drive controller board. And on that one, where is it? ADC88 CPU with RAM and ROM and clock and whatnot. So all this is handling, yeah, disk drive stuff. And I think we saw already here on the top board we already found the first ADC51 CPU or microcontroller with a lot of RAM and an external battery. And yeah, some interface chips and all that. Here on the next, this is the third board, 68008 CPU, and another ADC51. So we've got RAM and ROM probably for that one, RAM and ROM probably for that one, a little bit of interface chips and stuff. Maybe this is the main software package that runs the whole unit. That's at least something that I'm just guessing at the moment. We got the standoffs between the different layers, and they're all the same height. So lucky me. I think this standoff here is for the disk drive, and then just some screws, and then I will be able to remove this board as well. But I found a little bit of things I really wanted to talk about, some quality issues, and it goes a little bit again and again. See that track and the distance to that? This is the ground mounting. So depending on the ground, I mean, how you screw this in, you can damage this track. And this is the same problem on all the boards. This is the top board, and the screws they're with integrated locking. And look at the distance to that IC here. It's a half a millimeter. So depending on the alignment of the holes and the screws, and it's the distance to here, it's sort of fair distance. But I don't like any of that. This is how you have a problem. Of course, you don't expect all sorts of amateurs to do service on these, but at least you would like to have a little bit more safe distance in your design, right? And here the standoffs, they're really big. Look at that. So depending on how they are rotated here, you will almost touch the tracks. I mean, what do you think about that? After a little bit of cleaning in this area, I am very confident to say that for once it was not the reefer. And the burn damage you see on this red capacitor, I think it's of course because it came somewhere else. And I really wanted to change those diodes and clean the board under there. And why are we having all those integrated resistors right there? What is the point? That is weird. I was able to disconnect the CRT section here, and in one go we got some connectors for all that. The connector for the keyboard is very special. So the flat cable come in here, and it sticks to this sort of special connector. Here we got some little dots. Maybe we got a little springy things under here. The thing here that says snap, when you move this from left to right, those little metal pieces that you can see right here, they kind of lock in and out. And the idea is here on the circuit board, see they snap points here, but the lockers goes through the hole and locks in. I think that is a quite neat way to do it, but very special connector. So here on the main board, maybe this is for the keyboard reading, controlling, all that kind of stuff. And yeah, I think those will be microcontrollers and some RAM for that. And here is the connector that goes to the rear panel. Do you see something real funny here? That one is the Toshiba version of the Z80 CPU. That is impressive to see that one again, and more Zilog Z80 support chips, and of course the ROM and RAM for the Z80. So we got 5 or 6 CPUs running 5 or 6 different compilers so far, because here we got some different stuff going on, and this is the Z80, we got the 6800, we got the 80C51s, we got 2 of these, right? So that will be the same, but I mean, obviously this is assemblers and compilers. I don't know exactly what they use to write this, but I think it's really amazing to see that many different packages. I feel confident when I say it has to be in here. Some piece of metal touched the chassis, and you can even see the burn here through. So there's no need to search any deeper. It has to be this. I think this is a standard part with the mains filter, the fuse, and the on-off switch. Probably I could find something that fits the hole. I don't think there's anything wrong with any of this. Just the cleaning. I don't know if all this black stuff here is actually conductive. I should probably fix it a little bit better than this. I think this is as clean as I want to make it. Of course, it really helps removing all the components, and we can really see their burning flames went directly down to the diodes. So I will put in some new diodes. And the fun thing is about the 2 red components, one of them is a filter. So this is a common mode filter, and the other one camouflaged as exactly the same part. They even used the same plastic component to pot it into. That is just a capacitor, I think. But isn't it funny? So I think I'm ready to try and see if it is able to power up. I just connect to that little connector in here. So that means I don't have this power filter or any of that. So it should go on, or it blows up, I don't know. So meanwhile, I found all the documentation. We got some real thick books with all the operating manual, user guide for this and that protocol, getting started. That one was very useful. I read the first few pages, and so now I at least know how to read and install a program from a disk. So, and this is how you get this thing started. Data communication test library. I think that is exactly what I want to play with. We got all the utilities and a little bit of extra note about whatever we got here. And look at that. So you got the terminal emulator. We got some copy disk application. Aha, so this is how you copy the disk. So you need this program to be able to copy. They're probably in a proprietary funny format. I don't know if you can plug these into a PC or something. Maybe not. And yeah, just to show you, I got quite a lot of disks for all ISDN, this and that, and so I think it was a pretty good score here. Yeah, let's try and power it up. Maybe we should dim the light a little bit and see. It's using 28 watts. And I think that is fantastic. So I moved the camera a little bit. Let's try and see if we can figure this out. So this should be the VT100. So plug this in like that. And we should hit more. Then we should mass storage is this one. And here is the list of all the applications on this disk. So the idea is we use the arrow buttons here to select the right program, and we want the VT100, and I think it's just return, no, and it is just delete, load, aha, it is load, execute. So now it loads the program, and then what? Oh, we can set up. So we can set up board rates. Look at that. I hope this is nice and shiny here on the screen. Otherwise I'll move it a little bit closer like that. So if we look here, it's protocol, and we can probably change the code, display and whatnot. That is interesting. I'd better go and connect this. I'll turn it off, and then I will connect the breakout and see if I can connect this to a computer and get some data through this one. I am a little bit excited about all this. I'm super happy it works. I was able to connect this using the DB25 to my little USB breakout. This one I really like because we got LEDs here for transmit and receive. So it's super effective for debugging, and then I know what's going on here. And pin 3 is of course my TX from this unit. And then it goes into the RX pin 3 of this unit. And here's super easy because it's already written here. The pin 3 is the received data, and I got a little indication here on the LCD screen every time I push a dot or a knob or anything that I send. And here on the screen I can now see live what it is I am writing, but we have a little misunderstanding. It says carriage return. How cool is that? So I think it really works, but there is one more little thing, one last sad thing. I should probably show this if we hold everything. So if we hit more, there is a feature called self-test, and in the self-test, well, I think I want to show a little bit of the self-test. We got CRT tests, and it can do it can show all the characters of the ROMs, and we can see a video pattern, so you can align the screen and see the grayscales. I think we got, it looks like we got 2 grayscales, but that is not the case. I think it was only black grayscale and fully on, right? And then there is a keyboard test. So that is the sad thing that I wanted to show. So if we look at this little keyboard tester here, see, soft key 1, 2, 3, 4, 5, 6. All right, so all those works. And if I go down here and press the different, everything else seems to be working. But there is one up here. This one works. This one doesn't work. See, if I take something else and then see, this one doesn't work. But we also have here the numbers 1, 2, 3, 4, 5, 6, 8 works. So all those don't work. One line of this, and if we look at the layout here, this appears to be half of the keyboard. So I believe there is one line going to this scan of this that is not connected, and then there's something else. But if we remember when I started this video, the keyboard was super dirty, and somebody dropped a half-hour coffee in this or something like that. So there, I think there's something in the keyboard, so I need to open that and figure that out. But I don't want to make this video any longer and bore you with how to open a keyboard and how to clean that and see if I can figure that out. Anyway, I think I want to end this video right now. I hope you had a little bit of fun. See you next time. Bye bye.